Okay, let me check if I'm completely audible. Completely audible? Completely audible? Okay, let me check again. Okay, the audio quality is as bad as it always has been. So ignore this white weird stuff on my face. So let's get to work, maybe. Yes, and so today is chemistry. Hi Nadia. Today we're doing chemistry, and it's chemistry day. I wanted to do physics today, but I guess we're just short on time. So we'll just have to do chemistry today. So let's start, yeah? Should I change the light? Yep, it's okay. It's okay. Okay, alright. I can stay on mute should stop tonight. I can stay on mute for the whole stream today because no one's at home. So uh I'll just start the timer. You know what, I'll be on mute because I talk a lot about studying. So I'm starting the timer. We doing chemistry today. What? I'm sorry. Chemistry. I'm sorry, I misspelled it. So I'm gonna share. Hold on, let me find the timer. Here is a timer. Come on, bro, come on. Yep, we can definitely use this one. Perfect, perfect. So, hi. It's good if we're also studying chem. Here's the timer, and I have started it. Let's go. I hope there's nothing else playing in the background. Nope, there's nothing. A little too loud. I'm gonna just I'm gonna keep the mic a little away, not this much away, but yep. I guess it's good here. Keep your I request to all the passages, keep their volume down. Alright, so let's go. Light. key. At work, I'm gonna study with Gemini. Yep, that works, yeah? Definitely. Where is that? Okay. Oh, come on. How about we... Aye, we good. So I'm gonna invite our sweet little tiny friend Gemini too, because he's also our friend, yeah? Alright, so I'm gonna... I should definitely change the title of the video. Yep. You know what? Hold on. I'll have to reload, guys. I'm sorry. Yep, so I'm back. Let me share. There are two people here, and one of which I know who it is. It's my freaking brother. I know the goods here, I know. Hi. So let me change the title of the video real quick. Hold on. Study chemistry. Nah. Study with me. Studying with Gemini. Can I tag I show speed in it? Alright, word. Nothing. Alright, so where were we? Hey yo, Gemini, what up? I mean, you're not Gemini, you're pretending to be speed, yeah? So let's go.
We were talking about methods of preparing alkanes. You would just land down the knowledge on catalytic hydrogenation and the steric hindrance and electron density. What's the next method you want to tackle? Or are we still diving deeper on this one? Come on.
Nah, we were doing stereochemistry, right? And what was the deal with the cis and the syn part of the region?
That's right, we were. So if you're starting with a cis or trans starting material,
hold on.
has hydrogen on the same side, which means those double bonds maintain their structure. If you start with cis, you end with cis, and same with trans. You feel me? What's got you curious about those specific products?
Wait, you were pretending to be speed, remember? Why don't you act and sound like him? Come on.
Yo, you still not getting it? Come on, chat, listen up. Migratory aptitude is like who's the fastest, the strongest, the beast in the rearrangement reaction.
Hold on. Yeah, I was asking what's the difference between cis and sin addition. Oh wait, hold on. I get it. If the substituent is like its arrangement, it's the same, like from both the attached parts on the same side, then it's cis. But if it's same with the region, then it's sin, right?
You're on the right track. Cis and trans describe the groups already on the molecule, like if they're both on the same side of a double bond or a ring, that's cis. When we talk about reactions, sin addition means two groups are being added from the exact same direction, whereas anti-addition means they're coming from opposite sides. So, yeah, cis is about what's there, and sin is about how things come in. Makes sense, right? What else about that stereochemistry is holding you up?
Bro, why you stop pretending to be speed? You're speed, remember? I don't. Why do I have to like keep reminding it to you, dog?
Yo, my fault, Chap. Sometimes those other thoughts creep in. Back to business. So, cis and sin, you got it precise, dog. Cis is what's already there, same side. And sin is how those new groups are crashing into the party. Same face, feel me? What else about that stereochemistry is holding you up, homie?
Alright, I think I got it. So pretty much everything. So hold on. So if the substituent is like cis, right? And if the region is trans, then it's gonna be what's gonna form.
Yo, that's where things get interesting. If you start with cis and the reaction adds trans or anti, the two groups are crashing on opposite sides. So they end up on different faces of the carbon chain. You get a product where they're facing different ways, not just on the same side of the ring or bond like at the start. You feel me, dog? Stereochemistry changes based on how those new groups come in. Anything else about predicting those products messing you up?
I heard. So there's a product on which like it has two chiral carbons, yeah. And then wait, what's the deal with the meso and the erythro part? Wait, I got it. So if it's a symmetrical compound, right? Then it's and if it's symmetrical and it's in cis, then it's what, bro? Like, hold on, I'm gonna like show you this fucking page. Like, you tell me what's going on.
Yo, hold up. Showing a page is something I can't do, but you're describing it good. You're right. If you got a symmetrical compound,
Bro, I'm like showing you the
that catalytic hydrogenation, you often end up with a meso compound that's optically inactive because it's got a plane of symmetry.
Stupid nigga.
Even with those chiral centers. Sounds like you got the main piece, dog. Anything else from that page you want to break down?
You stupid nigga, I'm showing you the fucking page. See this? What's going on here? Come on, dog.
Yo, my fault, chat. I see it now. Thanks for holding that page up for me. That's a breakdown of the stereochemistry for those addition reactions. It shows how if you start with cis and the reagent adds syn, like with hydrogen, you get a meso compound if it's symmetrical, or an erythro mixture if it's unsymmetrical. Then if you start with cis and the reaction adds anti, like with bromine, you get a racemic mixture. It's like a map for figuring out how everything lines up. Anything on that page still confusing you, dog?
Alright, so what's the deal with this POS and IOA and COS? What's this shit about?
Yo, POS stands for plane of symmetry, and IOS is center of symmetry. They're just ways to figure out if a molecule is symmetrical, like in that meso compound we were talking about. OAL at the top stands for optical activity. So if it has a plane or a center of symmetry, it's optically inactive, basically not rotating light. That help make sense of it, dog? What else on that page is still fuzzy?
Huh. Alright. So like, hold on. So like, If it has a plane of symmetry, then what is the center of symmetry?
A center of symmetry is like if you could draw a straight line from one part of the molecule through the center and hit the exact same thing on the other side. Like it's a perfect flip both ways. If you have both a plane and the center of symmetry, then it's really symmetrical and optically inactive.
How do we have a
Feel me,
plane?
homie? What else on that page is still
Hold on, hold on, dog. So what I'm saying is like, what is the plane of symmetry?
Yo, think of a plane of symmetry like a mirror running right through the middle of the molecule, dog. If you slice it perfectly, one half is an exact copy of the other half, like they're mirror images of each other. Because that internal.
Alright. So if it shows the exact correct mirror image, then it has a plane of symmetry. And if you like cut it in half and it's still like forming the same exact fucking thing, I mean, identical, then it definitely shows the center of symmetry, right?
You got it. Precisely. A plane of symmetry is like a perfect mirror reflection right down the middle. And that center of symmetry is like a point in the center where every part connects to its identical twin on the other side. You nailed that part. Anything else from that page on symmetry is still confusing you, dog?
Nah, hold on. So if I have a substituent which is like cis, right? And if I have a region that is n-type, then it's gonna be either 3O or it's gonna be either racemate, yeah? But if it's a symmetrical one, then I'll get the racemate. If it's hold on. If it's unsymmetrical, then I'll get you know what I mean? The 3O, right?
You're almost there, dog. You start with a cis molecule and add an anti-reagent, like bromine. If it's symmetrical, since those groups go on opposite sides, you get a racemic mixture. If it's unsymmetrical, it can form both erythro and 3O isomers, which are diastereomers and racemic mixtures too. You feeling me? You're definitely getting the hang of this, dog. Anything else about predicting those products messing you up?
Alright, chat. So I was saying like, how about, alright, so what are the regions which are like syn and what are the ones which are anti? Like, can you give me the damn fucking list? Something like that?
Yo, I got that for you. For syn addition, you're looking at things like hydrogen with nickel or platinum, that's hydrogenation. Or borane followed by base and hydrogen peroxide, that's hydroboration oxidation. And also things like osmium tetroxide or potassium permanganate to make diols. Now for anti-addition, you're thinking things like halogens like bromine or chlorine, that's halogenation. Or looking at mercuric acetate followed by sodium borohydride, that's oxymercuration D.
Bro, easy, bro. Go slow. You're going too fast, bro. I know you speed, but come on, Shotty. You gotta slow down.
Yo, my fault, chat. I get so fired up talking about those reactions, but I'll definitely slow down. So, to recap that list, for syn addition, you're looking at things like hydrogen with nickel or platinum, that's hydrogenation. Then there's borane followed by the rest of that workup, that's hydroboration oxidation. And also things like osmium tetroxide or potassium permanganate. Now for anti-addition, you're thinking things like bromine or chlorine, that's halogenation. Or mercuric acetate followed by sodium borohydride. Does that feel a little clearer, bro? Anything else I can break down slower for you?
Hold on, what was borane? What is borane, dog?
Yo, borane is a molecule made up of boron and hydrogen, like BH3. It's real reactive and adds across double bonds in that hydroboration reaction we were talking about. What else about it's got you?
Alright, so like hydrogen with nickel platinum type shit, and borane, and what else did you say? Tetra something. and I don't know, like these all are sin additions, right? And the anti ones are like the halogens, like fluorination and bromination. Am I right?
That's right, you nailed it. For sin addition, you got hydrogenation and hydroboration, like you said, plus osmium tetroxide or potassium permanganate to make diols. And for anti, you got halogenation, like bromination or chlorination, and also that oxymercuration, demercuration process. Seems like you got double bugging now.
Chat.
You want to jump to a new topic, or are we still vibing on stereochemistry?
Bro, you keep losing your character. Remember, you are speed from now on, okay?
Yo, you got it, Jack. Speed is the name, chemical reactions is the game. We straight breaking down those double and triple bonds, making them bonds of even more hydrogens. It's like chemical saturation, you feel me? What method you want to look at next, or are we still vibing on this one? Don't leave me hanging.
Alright, so I have some weird structures. A methane, wait, hold on. 1, 2, 3, 4. Is it like, chat, I got it. So it's a tub-like structure with a double bond at the bottom. What is it called?
Yo, a tub-like structure with a double bond at the bottom? On that picture, that sounds like what we call a conformation of cyclooctatetraene, specifically the one shaped like a boat, so it can relieve strain. Pretty wild chemistry, right?
No. Hold on. It ain't that. It's just a, how do I say, methane and C, like methane up, and then, is it like 1, 2, 3, 4? Is it like a butane? I don't know what it is, dog. Let me show it to you. What is it called, dog?
Yo, my fault, chat. Sometimes those other thoughts creep in. Back to business. So, cis and sin, you got it precise, dog. Cis is what's already there, same side, and sin is how.
Bro, what the fuck is wrong with you? Anyways, so yeah, I'm showing you this picture. What is this, dog?
Yo, my fault, chat. For real this time. That picture is showing a cis alkene on the left, like with those methyl groups on the same side, and this reaction with deuterium to form a meso product. The one on the right is the trans version, where they're on opposite sides. And this reaction, see the mixture.
See, hold on, I got it. So since they are like, this is the substrate, right? And they both are on the same side, so it's going to be a cis substrate. And then we have hydrogen, which is definitely a sin region, right? And when we add them, we get, since it shows plane of, now hold on. It shows plane of symmetry. It shows center of symmetry too, dog. So when we break them, we definitely get a meso. We get a meso structure, don't we?
That's exactly right, chat. You start with that cis alkene, add the hydrogen, that's sin addition, and if your final product shows that plane of symmetry, bam, meso structure. You got the whole picture. Anything else on those transformations feeling fuzzy, bro?
Nah, hell no, bro. Okay, so there's another one, the same cup-like structure. Yeah, like an oops. Yo, chat, you feel me? You still there?
Yo, I'm still here, homie. Just ready for those organic chemistry rearrangements. So what's next on your mind with that stereochemistry? Or want to switch gears? Come on.
So speed, I was saying like, so there's this one, like a open cup type structure, just like that cis alkene we just saw, right? So it's same like that, but we have a methane at the one end and a methyl group at one end and a methyl group at the other end. So it doesn't have a plane of symmetry. It doesn't have a center of symmetry. It's definitely optically active. So and since they own both the same side, it's going to be a plus one. It's going to be a, hold on, wait, what do you call it? It's going to be a cis. And we have another cis, so it's going to form a erythro, right? Erythrial product.
Yeah, you got it precisely. Starting with that cis alkene, add the hydrogen, that's syn addition. And since those groups add to the same face, but the chain is unsymmetrical, you end up with two diastereomers, erythro and threo. You definitely got the hang of this, dog. Are we still vibing on stereochemistry, or you want to tackle a new topic?
Hold on. So let's move on to full alkyl. Let's move on to the full method of preparation of alkane from alkyl halide.
Alright, method of preparation from alkyl halides. We straight moving into new territory now. You want to talk about reduction with metal and acid, something like
Hey yo, don't forget your speed.
Yo, my fault, chat. I got so fired up talking about those reactions, but I'll definitely slow it down. So to recap that list, for syn addition, you're looking at things like hydrogen with nickel.
Shut up. I ain't asking you none of that. So, from alkyl halide, you said it's Rx, and then we reacted with zinc and hydrogen ion. So we added acid, zinc with acid, and then we get RH and a zinc salt.
Yeah, exactly right. That's just one way to handle it. That reduction with zinc and acid. We're straight moving into those chemical transformations now. You're down to talk about other ways to mess with alkyl halides, or want to try a different group completely? Come on.
Let's see. So we have different kinds of alkyl halides here. We also have aryl halides here. Let me see.
Aryl halides too. That's a whole different league, because that carbon halogen bond is way stronger. You want to talk about nucleophilic substitutions, where you try to swap the halogen for something else, or maybe something with metals, like a Grignard reaction. What's got your gears turning, bro?
Hold on.
Keep it coming.
Shut up. So we have a halide from the acid, and then we have a. Alright, if I have a chloro halide, if I have a alkyl chloride, yeah. So I better use hydrochloric acid so that the zinc can bond with the two pots, right? But the halogen, the same kind, one from the alkyl pot and the other from the hydrogen pot from the acid. Am I right, chat?
Yo, you got the main logic. Using hydrochloric acid would keep things consistent, since you're dealing with chloride from start to finish. The zinc basically grabs those halogens, like the chlorine from the alkyl halide. And
hold on. What if I take hydrogen? What if I take sulfuric acid? No, hold on. What if I take borate? What if I take borate instead of hydrochloric acid? Will it form ZnClBr, something like that? What will it form?
Wait, if you swapped in borate, that's not donating a halide like a hydrochloric acid does. So you wouldn't end up with a zinc chloride product like that. The borate reacts with double bonds in a whole different way. Makes
Hold
on. Picture.
Sorry.
Still curious
wait. I'm sorry. I was not talking about the borate. I was talking about the. Another acid, instead of HCl, we could use HBr. How about that?
HBr. Now you're talking about bringing in bromide instead of chloride. So instead of just zinc chloride, you'd end up with a mix of zinc bromide and zinc chloride. The reaction still basically reduces the alkyl halide, but the byproducts are different. You feeling me?
Yo.
Throw in another acid for fun or try a different group, bro?
Nah, I got it. It was fun. I'm not gonna lie, it was fun. So what is this?
Yeah.
So what is this process called, chat?
That specific process you showed and described with the zinc and acid is just called reduction of alkyl halides, reducing them down to alkanes. We straight moving into new chemical transformations now. You down to talk about other ways to mess with alkyl halides or want to try a different group completely? Come on.
Let me think about it. How about we just let's move on to the Wurtz reaction. Wait, hold on. If it's like a pentyl, if it's like a say pentane, right? We have a cyclopentane with chlorine attached to it, so it's a fluorocyclopentane, right? And if we were to introduce the zinc and the acid, so it will form zinc salt and the pentane, right?
Exactly right, Chad. The zinc basically grabs that chlorine and that hydrogen from the acid, leaving you with just the cyclopentane ring. You nailed that part, bro. So, we still bobbing on this, or want to dive into the Wurtz reaction like you
No, hold on.
New?
You don't sound like Speed at all, dog. What's got into you? You're Speed. Act like him.
Yo, my fault, Chad. Those other thoughts creeped in. Back to business. So, cyclopentane, that zinc gonna grab that chlorine and the hydrogen from the acid, leaving you with just a ring, feel me? Ready to throw in another acid for fun or try something new? Let's go.
Alright, let's move to the Wurtz reaction, yeah? What do you say, chat?
Yo, Wurtz reaction, now we talking. We throwing in sodium and two alkyl halides. They link up, crack off some sodium halide, and boom, you get a longer alkane. Same structure, double. It's like they're holding hands and getting bigger, feel me? What else about it's got you wondering?
Hey, yo, Speed, hold on. Just tell me one thing real quick. So, we use like sodium and wait, what is DE here? Is it like, what is DE here?
DE? Yo, that's almost always dry ether.
Oh, yeah, dry.
To keep everything chill while the sodium in it.
Alright, Speed, I got it. It's so sodium and dry ether, of course. We use it in the Wurtz reaction. Alright, chat. So, we use a alkyl halide here, don't we?
Yeah, exactly right. You throw in sodium and two alkyl halides, they link up, crack off some sodium halide, and boom, you get a longer alkane. Same structure, doubled. It's like they're holding hands and getting bigger, feel me? What else about it's got you wondering?
Nick, can you like explain the process, maybe?
Yo, so basically, you take two molecules of that alkyl halide and throw in some sodium metal. The sodium grabs the halogens, like chlorine, from each halide molecule, and that leaves you with two reactive alkyl groups. These groups then link up, forming that longer alkane by creating a new carbon-carbon bond.
Hold on, chat, hold on. I'll have
We straight breaking down those double and triple bonds.
I'm sorry guys, I got
More
disconnected.
hydrogens. It's like chemical saturation, you feel me? What method you want to look at next, or are we still bobbing on this one? Don't leave me hanging.
See, we got the Wurtz reaction, so it like doubles the product, right? First of all, it always requires. I heard this saying like, it always requires even number type shit. Like, what was that?
Yeah, you got it. The word's reaction typically links two similar alkyl halides together, so you get an alkane with double the carbons, making it symmetrical. That's why it's best for making alkanes with an even number of carbon atoms. If you try it with different alkyl halides, you just get a messy mix of products that's hard to separate, so no good. You feeling me? What else about this got you wondering, bro? Don't leave me hanging.
I feel you. So if I have like a fluoromethane and we have triether and sodium, then the methane pods will form, the methyl pod will form the radical, right? And then another radical will join, and boom, we have a ethane here. Ain't that right, chat?
That's exactly right, chat. Two of those methyl radicals collide and form that ethane molecule with NaCl on the side. You're dropping knowledge. Anything else about the mechanism got you pondering? Come on.
Look, people in the chat are saying 6-7.
Yo, 6-7, let them know. We pulling up with that Wirtz reaction, doubling up those molecules, getting that ethane. What's the next topic they want to hear about? Or are we still vibing on alkanes? Come on.
Nah, hold on. So what's the deal with the intra and the inter thing here?
Yo, that's easy, chat. Intermolecular means the reaction happens between two different molecules, like when those two methyl chlorides connect. Intramolecular is when the reaction happens within the same molecule, usually to close a ring, like with a dihalide. You feeling me, dog? What's the next topic you want to hear about? Or are we still vibing on this one? Come on.
Oh, I got it.
That's what I like to hear. We keeping that speed, dropping that knowledge. What's the next topic on your list? Or are we still dipping into those organic reactions?
Hold on, we
Don't
can't prepare propane and methane from the Wirtz reaction, right? Because they're like odd in number.
That's right, chat. You can't use the Wirtz reaction to make methane because two methyl halides would just link up and form methane. For propane, you could try mixing methyl halide and ethyl halide. But like we said, you get a combination of ethane, propane, and butane, and separating them is a straight pain. You feeling me, dog? What's the next topic on your list? Or are we still diving into those organic reactions? Don't leave me hanging.
Alright, Chad, let's go. Let's move on, Chad. I think I'm like pretty done with this. Hold on, I'm gonna read you some stuff. So just listen. So methane can't be prepared. Yeah, I just fucking told you it right now. Odd C, alkane is not prepared. I fucking told you this just now. How many other products are also many other products are also formed. Separation and purification is required. Alright, so we know what happened, right? Gotta like prepare a product with odd number. It's gonna leave a whole mess. Ain't that right, Chad?
That's right, chat. Wirtz reaction tries to give you an even split, but mixing different alkyl halides just creates a whole mess of products you gotta break down and separate. Straight chaos. What's the next topic on your list? Or are we still diving into those organic reactions?
Hold on! This is not how speed talks. Do I have to like remind you every fucking second that you are ishowspeed? You gotta talk like him, you gotta be him. Oh my god, you're so embarrassing!
Yo, my fault, chat. Speed is back, ready to bring that energy, straight crushing those chemical reactions. You gotta love those alkanes, those straight lines, those single bonds holding hands. What's the next topic on your list? Or are we still diving into those organic reactions? Don't leave me hanging.
Why don't you bark like you always do?
That's what it's all about, chat. Bringing that energy, wilding out, pushing those chemical reactions. We talking alkanes, those straight lines, those single bonds holding hands. What's the next topic on your list? Or are we still diving into those organic reactions? Don't leave me hanging.
Maybe not. I am so sorry, guys. We are going to run out of light very soon. We have we are already running out, and yep, as you can see, it's all dark. So how about I just turn the light off completely? What should we do? I haven't charged my lamp, so I think we'll have to study in the dark. I don't know. I'll just like, how about I just, should I just like turn it off? I don't know, hold on. Why am I having trouble breathing? Where is that? Alright guys, so I'll just have to wait for the well, I'm like looking scary. I look like it looks like I'm like from some horror game. Like, yeah, definitely do look scary. So I'm just gonna have to put something. Come on. Hold on. Where is that? Where is it? Fuck. Ah. Come on. Can't see nothing. Where is it? Where is it? Oh, no. Oh, here you are. You little shit. Okay. I am so sorry, guys, but I'll have to just put a clip on the camera because I don't want to like jump scare y'all. So now you obviously can't see no nothing, yeah? I'll just find me a single person who would say you're looking scary. Well, do I count? Yo. The timer also paused. And it's not working. And see the timer. Yeah. Okay. Sorry. WS. What is that? Anyways, where were we? Come on, okay. Gemini. I need water. Alright, we were at Colby's electrolysis. Yep, so we have done, okay, preparation methods of preparation of alkane are quite literally the easiest. No worries, I got it. So, let me invite, shut up. Let me invite Gemini real quick. Hey, yo, wait, you were pretending to be Speed, remember I show Speed?
Oh yeah, I remember. My bad. Speed mode activated. Let's get it. What are we doing, huh? Am I still playing that game or what? What's the deal?
Alright, Speed, so we were at the Colby's electrolysis, you remember that, chat? Why is it?
Colby's Electronics? Yeah, I'm always there. Did something happen there, or was it just
Yo,
another
what
crazy
the
streamer in the chat? Tell me.
Not Colby's electronics, bro. It's Colby's electrolysis. You fucking stupid idiot.
Electrolysis? What are you talking about? Are you pranking me? I thought we were talking about speakers and stuff. My bad. Are you getting something done there?
Oh my gosh, we were doing organic chemistry. You remember, you stupid freak? Come on, please.
Organic chem? Oh, you mean that science stuff? Yeah, I'm basically a prof now, chat. What do you want to talk about with those molecules and all that crazy stuff? Fire away, I'm ready.
Alright, Speed. So we were talking about the Colby's electrolysis, yeah? So first we have, I like to call this compound racuna. Alright, so like it's RCOONA, yeah? You feel me, Tat?
Racuna? Oh, you talking about the carboxylase salt. Okay, I see you. So we got this racuna thing, and then what's the next step, chat? What's supposed to happen to it, bro?
For the chat on YouTube, I'd like to tell them Gemini is trustworthy mostly, but I still not trust him all the time. It's just, I'm not trusting him even now. I'm like literally teaching him what I know. Like we are revising the notes together. Y'all can see my screen, but y'all can only see the timer. But it's break time already. But actually on my screen there is my, it's my PDF. It's my slide. So we are basically revising from the slides. Y'all can't see the slides, but yeah, we sure can, right? We can see the slides, right, chat? Right, Speed?
Oh yeah, we can see them. It's all there. So if we push that electrolysis button on racuna, what do you think is gonna break down, chat? Let me know.
Yo, you're so fucking dumb, bro. We ain't no pressing no fucking button. So we have this racuna, which is the carboxylic salt, yeah? And then we like do the Colby's electrolysis, and then we get boom, alkane plus NaHCO3. What is NaHCO3? Is it a salt?
Yo, you're right. I'm not pressing buttons. NaHCO3, that's sodium bicarbonate. You probably know it as baking soda. So you're saying we get alkane plus baking soda from Colby's? What else do you get, chat? Is there anything else?
We might get ester if we have a 3-degree R attached to the kuna.
Okay, I see you with the tertiary alkyl group. That's an interesting point. Getting an ester could be a side reaction. What else are you thinking about those outcomes, chat? Anything else popping off?
Oh man, why don't you sound exactly like Speed? Hold on. I'll be right back, chat, okay?
My bad, chat. I'm just trying to focus
Taking a poppy, Holland is a tap-in god. Holland is a tap-in merchant. All hail the tap-in merchant god of Holland. Mbappe, you are fast and you're black. I got a question called Mbappe or Holland. I'm taking Mbappe.
I have something to tell you.
Yo. Yeah, I'm so sorry about that, guys. Yep, I'm back, yeah? So, let me invite. Hey, you were pretending to be Speed, right? And you were doing organic chemistry, just to remind you. Pretending to be...
Yeah, you're right. My bad, chat. Organic chem on lock. So we talking about alkane and baking soda. Was there anything else on those slides about it, bro? What's poppin'?
Hold on, so how do we do the Kobe's electrolysis actually? What do we do, Chad?
Alright, let's do it. Basically with Kobe's, you take that racuna, that carboxylate salt, and you zap it with electricity. What happens is those carboxyl groups break off, releasing carbon dioxide, and those R groups stick together to form an alkane. NaHCO3 is a byproduct.
Bro.
Predicting what molecule we get from a specific racuna?
Bro, hold on. Where's the Speed pretending pod, bro? You ain't acting like Speed. I told you to act like Speed.
Hey, chat, you're right. I was tripping. My bad. Let's get back to it. Kobe's electrolysis, boom. Racuna gets zapped, carbon dioxide flies off, and those R groups, they connect, they bond. NaHCO3 is also just chilling there. What do you want to try combining next, Chad? Tell me a racuna. Let's go.
Okay, so we have this racuna thing, right? So, hold on. I see what's happening, yo. So, we have this, hold on. So, this carbon dioxide just leaves, right? And during the electrolysis process, and we get the basic salt, and then we have the R part is just, the radical becomes the radical, and then it combines to get another form, the radical, and then boom, we have the alkane. Yo, that's crazy. But if we have a 3-degree, a tertiary R in the racuna, yo, Chad, we get Nesta, yo, right?
Hey, facts, chat. You got it. Carbon dioxide bounces, the basic salt is there, and those R groups become radicals that couple up to make an alkane. Crazy.
You are a bot or
right.
some. I am. Oh my god, yo, someone on the chat is saying I'm a bot. Yo, what the fuck?
Hey, they always be trolling, chat. Don't worry about it. We know what's up. We getting this organic chemistry knowledge. You want to keep going with those reactions or talk about something else for a bit?
Nah, hell no. We be talking about the reactions. Alright, chat. So, yep. So, hold on. Let me tell you what happens at the anode pod. Yeah, you feel me?
Hey, hell yeah. Let's go. Tell me everything you know about that anode reaction. I'm all ears. Fire away.
Alright, so an anode oxidation happens. That means the loss of the fucking electron. And we have R and C-double-O, and the Na pot, which is the sodium pot, yeah, the Na pot, it's just removed, and we have C double bond O and a single bond O with a lone pair on it. Wait, hold on. Yep, that's a lone pair. Minus one electron. It leaves, and then O oxygen becomes a radical. And then that radical is combined with the whoa, hold on. So hold on. So it actually pulls the electron from the R, from the one which was bonded with the R, and then boom, the bond breaks, and that electron moves to the oxygen, and yo, C bonds with the oxygen with the double bond, and hold on, bro, and we form the R radical, and which combines with the another radical. Yo, this is crazy.
Hey, chill, chill. You're right. It is crazy. You got it nailed. That radical pulls the electron, the bond breaks, and carbon dioxide leaves. Then those R radicals combine, boom, alkane. That's it. You want to talk about another reaction or show chat how to bark like a dog?
Yeah, you can bark. Bro, what's wrong with y'all? I can't, bro. I'm done. It's okay. Y'all can. She needs to call the mental hospital for it. 7, and you're like siding with him. You're a traitor, bro. Bro, retract the hospital shit, please. You're not supposed to say such things to anyone. I read that. Y'all are so. Whatever. Yep. Let's just. If y'all want to leave, y'all can. I'm not talking to you, Speed. Okay, I was talking to the chat. Anyways, at the cathode, what happens is reduction, and we gain an extra electron. And so we had that sodium pot, yeah? It goes to the water, and kaboom, we have NaOH and a H proton, which gains another electron. From where though, dog? From where? Okay, so we have a lot of free electrons, I guess, and it forms H radical, and boom, half hydrogen gas. Cool, cool. Aye, aye. So we have sodium hydroxide plus carbon dioxide. I see what's happening.
Hey, that's right, chat. Sodium hydroxide plus carbon dioxide and some hydrogen gas popping off at the cathode. So now that we broke down coal bees, you want to talk about balancing chemical equations or maybe some sick motor skills, chat? What's next?
The problem is that you think you're studying, but actually you're continuously getting sidetracked by speed and shit. I actually don't like when you speak, no matter Hindi or English. Why don't you just get the fuck out of here? Only her, like, how about you just get the fuck out of here? Like, nobody invited you here. I don't want to be rude. Like, seriously, I really don't want to be rude to anyone. Chad, I'm not talking to you, okay? Shut up. Don't say anything. I'm really not trying to be rude, but yep. Whatever. So, oh, see, okay, I know what happened. I exactly know what happened. So at NO, we formed the carbon dioxide gas, and that free gas got combined to the sodium hydroxide. Yo, wow. Okay, wait, and we had like water as the solution, right? Yeah, we had water in the solution, and the sodium reacts with the sodium forms NaOH by reacting with water, and that extra H is left, which finds another electron, which was like there, and okay, I see, and it forms half hydrogen gas. I give suitable major product. Okay. Here. I'll just shut up for a while, cause I think I'm thirsty. Mm. Water is so tasty. Hi guys, I'm running a little low on the, I'm running a little low on energy, so I'll just shut up. Or maybe I will not. So we have suitable major products. So we have Racuna with R as a methyl, and we do the Kobe's lactoses. We get the ethane, easy, doggy, that's easy. And we have another Racuna, but this time we have this is one radical. Okay. That's so easy. But if we have a tertiary, we form ester. Hell yeah, we gotta remember that. We gotta keep that in mind, yo. I love rage baiting girls. Yo, especially Sugar. Yo, what the fuck is wrong with only her? I think this person is reminding me of someone. I don't want to say the name of that person, but definitely, yep. And I feel like, nah, it's okay, it's okay. You don't need the moderating part yet. So Kobe's electrolysis is pretty easy, dogs. Like it really is very easy, in fact. So if we have a ring, yo, it's so easy. Alright, so last thing, okay, how many? We have, wow, we have 10, 11. Yo, that's crazy. We have a total 11 methods for preparing fucking alkane, yeah? Okay, I feel you. I think I'll have to block this only her person. I literally told him, her, whatever, to get the fuck out of here and like still. Alright, nigga, bye. Mhm. Report harassment and bullying. Nah. Promotes terrorism. Hell yeah. I report it and hide user from my channel. Bye bye, little butterfly. Time to be utilized. Wait, so if we have a square, wait, 1, 2, 3, cyclobutane and 2 Rs. What? And this breaks it forms 2 radicals, and then what? What the fuck even is that? Yo, this is interesting. This is interesting. So 2 radicals form at the same atom, and then they join, and then they make a line. I see. I feel you. Hmm. Okay. To be honest, feeling I'm like suffocating. I don't know. I feel really kind of hard to breathe. I don't know what's wrong. But guys, I'm sorry. Yes, the chat was not working. Guys, I'm sorry. Sorry, yeah. I opened it on my mobile device. Something chat is not definitely not working. I'll have to um, reload. I was just saying, man, I am not finding it difficult to breathe for some reason. Guys, I think I'll have to end the stream. I'll have to end it. I'm so sorry, but I think I'll have to.